Hello everybody, my name is Edgar and today I'm back for another lesson. This time one on data analysis and data visualization. So without further ado, let's get started. As you can tell from my workspace, we'll be using Google Colab today. I already have a blank one open and ready to go. And if you're observant, you'd also notice that I already uploaded my own CSV file that we'll be working with today. Now I got this CSV file from a website called Kaggle. This particular one is called Student Performance in Exams for the purposes of this lesson. But if you're following along to this lesson, feel free to use the same CSV file from Kaggle or go ahead and create your own. The same steps should apply for just about any set of data on a basic scale. Once you have your CSV file uploaded to the Colab workspace, then the first thing we're going to want to do is import our necessary libraries. So the only one we'll be using today is Pandas, and I'm going to go ahead and import it Pandas as PD and run it just to make sure it's loaded. And the reason we're importing Pandas is because Pandas is a very powerful data analysis and data manipulation tool, which is, for all intents and purposes, all we want to do today. Now, once we have the library loaded and ready to go, it's working just as intended. So I'm going to go ahead and create a variable called df. This is going to store in DataFrame, which is a custom data type from the library Pandas. And I'm going to go ahead and do pd pandas.read CSV file. I'm going to do a CSV, and I'm going to import the CSV file that I already have loaded. So I'm going to right click the file I want to use, and then I'm going to paste it right here. Once I have that, I'm going to go df.head, and then I'm going to do 10. So what this should do is it should read in the CSV file, and then once I read it in, I'm just going to print out the first 10 characters. And if my code is correct, I should see almost this exact screen. So let's run it, let's test it. And yes, indeed, we have the first 10 rows of data from our file. Now that we have shown that we could successfully load our CSV file, then let's look at some of the unique ways in which we can organize that data by printing it out and seeing some of the changes. Let's create a new code block down here. Just like before, we're going to load in our data frame variable df, and I'm going to create two square brackets. Now inside these square brackets, I'm going to create single quotes, and let's say we want to look at parental level of education, right? So the first thing I'm going to do is I'm going to copy this header. I have to type it in exactly as it's shown up here. And inside these single quotes, I'm going to paste it. So if I run this, you'll notice that it will print all of the values in the parental level of education. But say I don't want to print out the first 1000 values. Let's say I just want to see the first 15. So I'm going to type in .head, and I will mention I only want to see those first 15. So if I run this, you'll notice now we're only seeing that range of values. I could change this to also be the last 15. So if I press tail, I'll notice the last 15 values of that CSV file. But how would you print out multiple columns? So say I want to look up parental level of education and their test preparation course column, right? So I'm just going to add a comma right here and copy just like I did for the parental level of education. So I'm going to copy over here, Control C, and then in between the single quotes, I'm going to paste it. Make sure it's exactly the same and run it. And as you'll notice, we now have 3 columns: the row number, the level of education of the parent, as well as if they took a preparation course or not. Now that we've seen how to print columns, how would we print rows? Now to print a row, we could do df just like before, but instead we're going to type LOC, which stands for location. We're going to bring back those brackets, this time only one pair, and we're going to type in the row number we want to see. So I want to see let's look at row 3. We're going to type row 3. I'm going to type in a comma because the function LOC is going to take in two parameters, a row number and a column name. But we don't have to specify a column name. If I type in a colon, then it's going to print out everything in that row. So let me run it just to prove it. And as you'll notice, these are the column names, and it's printing out the value of that name in that name. So gender has male. Is that the case? Gender male. Group A, associates, free, reduced, none, and so on. It's printing out everything in that row. But say we wanted to print out multiple rows, just like we wanted to print out multiple columns. We're going to change that to a range then. By using the colon just like before, we could print out everything from 3 and on. If I leave it blank, it'll print out everything from 3 to the end of the CSV file. But I could also limit it by printing out from 3 to 10. And now we're only seeing the rows 3 to 10. And just like I could specify the range of the row, I could also specify the range of the columns by typing in the column I want to look at. I want to look at parental level of education just like before. I'm going to make sure it's exactly the same, and if I print it out, now you'll notice that we're only seeing the parental's level of education for rows 3 to 10. And now that we've seen some ways to isolate aspects of our data, let's learn how we could turn that skill into visualizing our data through graphs and plots. So in order to do that, let's find ourselves another code block. And the first thing we're going to do is we're going to pick a column. I want to pick out the math score column. So I'm going to go specify the data frame, DF, and then inside type math score in single brackets. It's got to be exactly how it's in the header. And what I'm going to do is I'm going to count the value. So I'm going to go value count parentheses. And what this is going to do is it's going to go to our column of math score, and it's going to count how many times everything shows up. So how many times does 72 show up? How many times does 90 show up? And once it counts it up, it's going to group them and we could now plot it. So we're going to plot it, and I'm going to specify that I want a pie chart. So if I run it, we should see that we now have our graph. It's not a very good graph. It's very messy. It does the job. We see that a lot of people seem to got a 65 and a 62, and we could see the scores people got. But there's so many scores that it gets kind of cramped. So let's clean it. Let's make it nicer. And we're going to do a process called data cleaning, which is when we take the original data and modify and mask it or replace it or modify whatever so that it's easier for us and the computer to read. I'm going to keep this one exactly the same and create another block of code. And down here, what I'm going to do is I'm going to create a copy of our data. Now, our data is the math score column. So I don't want to modify that data, because if I mess it up, I have no way of getting it back. Theoretically, I could download it again and do this huge long process, but why take that risk when I could simply create a copy of that column? So the first thing I'm going to do is I'm going to create DF, and I'm going to create a brand new column. So instead of using one that already exists, I'm going to use one that doesn't exist. So I'm going to do new scores. Now new scores is going to be a column that I just created, and I'm going to set it equal to DF. I'm going to set it equal to DF data frame math scores. And if I print it out just to make sure, I'm going to go DF using the skills we just went over. I'm going to DF, I'm going to print out new scores, new score, comma, math score, in quotes, math score, and I'm just going to print out the first 10 for good measure. Now run it. You'll notice that new scores is exactly the same as math scores. And now we can modify new scores without worry of messing up the original data. So let's do that. Let's change all these so that it has a letter grade instead of it has like an A, B, C instead of the actual number. And this will make it look a lot nicer for our pie. It would make it look a lot nicer in the pie chart. So what we're going to do is we're going to go DF. I'm going to take new score, and I'm going to set it equal to DF. I'm going to grab new score, in quotes again, new score, and then I'm going to mask it, dot mask, and then pass in the parameters. Now inside these parameters, we're going to have the original data. So I'm going to go df math, I keep forgetting the quotes, math score. And when I mask it, I'm going to give some kind of equation so I know when to mask it. So let's start with doing the grade for A. So if it's less than equal to 100, I want to give it the value A. So I'm going to test it. Let me make sure that's working. Oh no, what did I do? Is not supported instance of str and int. Look at that. Look at the simple error I made. I forgot the closing bracket there because I accidentally put it over here. There we go. And if you notice, now all of our values are A. But that's not what we want. We want to be more specific. We want to have B's and C's and D's. So let's start adding the values for that. So B, when this is less than equal to 90. So just like before, new score is going to be mask when the original score, mask score, is less than equal to 90. Okay. No, not equal to. We just want less than 90. And we should get a B when it's less than 80. We should get a C when it's less than 80. A D when it's less than 70. And an F when it is less than 60. Now one more check just to make sure it's working. A 72 is a C, that checks out. A 69 is a D, that checks out. A 90 is an A, that checks out. From the looks of it, our data is good. I'm going to check a few more just really quickly and make sure I don't see anything not working. And no, I think we're all good. Perfect. Now that we've changed the values, let's see how it looks like when we graph it. I'm just going to copy this value once again, and I want to run it. But instead of using math score, I want to look up new score. They got to be exactly the same. And voila, we now have a much cleaner and nicer looking pie chart. But we could actually take it one step further. If you notice, our plot is kind of pie, but we could actually add more parameters so that it looks even nicer. Now you could find a list of all the parameters in the Pandas documentation. You could just Google Pandas plot documentation, and I believe it's this one. And when we do that, these are all the parameters you could put inside plot. I already done this a few times, so I already have a list of parameters I want to include. So if you guys want to follow along and use the same ones I do, we're going to do kind type pi. That's one of the parameters we already had. I'm going to give it a title, and I'm going to call it grade by letters. Grade by letters. I'm going to do, don't forget the comma, legend equals true, and let's, with a capital T, and let's just make sure this is working so far. So I'm going to run it. So far so good. I'm seeing changes. We want to have legend equals true. I'm going to change the Y label to the Y label being this new, the name of the column right here. I want to actually call it something else. I'm going to call it data from Kaggle. I'm going to call it data from Kaggle. I'm going to get rid of these annoying, this repetitive labels on around the circle. So I'm going to call labels labels equal none with a capital N. And then lastly, I'm going to give particular colors. Colors is equal to, and then I'm going to create those square brackets. Now there's many ways you could use colors. You could do hexadecimal, you could use HTML color codes. I already have some different variations of how to type it. So I'll just show you all the ones I have. BD. Oh, these have to be in single quotes. BD, BD, BD. I could also use the label just gray. And then I could use RGB, which will be 0.3. Not in the traditional sense where we have a number. It's more like a decimal value, but it's still using RGB. 0.3, 0.3. And there's also a shorthand for some very popular colors. For example, B equals blue, K equals black. So assuming this is all typed in correctly, if I run it, oh no, what did I do? No, since I'm using hexadecimal, I have to specify that I'm using that. And boom, we now have a much fancier looking pie chart. We specify the colors using a variety of different methods. We change the label, we gave it a title, and look how much better this looks compared to our original graph before we cleaned the data, before we added parameters. And now that we've created a pie chart, let's go ahead and create a different type of chart. Let's create a bar chart. So let's go back down, and I'm going to actually create a new text box down here. For a bar chart, it's going to be more or less the same steps. So same first steps. So let's take a look at the columns, and let's look at the gender. Let's say I want to look at this distribution of male and female students who took the exam, right? So I'm going to call same data frame from before. I'm going to do the exact same step by specifying the column name by gender. I'm going to count the values just like I did for the pie chart, value counts, and then I'm going to plot it. And can you guess the difference from the pie chart? The only difference is going to be that instead of kind equals, I'm going to do kind equals bar. I'll run this, assuming I spelled everything correctly. You'll notice we now have a bar chart of all the values, but as you can see, I've modified the data for the purpose of this lesson so that it's messy. Some people typed it with capitals, some did all capitals, some put boy, some people put girl. It's just a big jumbled mess. And I did this just so that we could practice data cleaning on text instead of just numbers. So, just like before, let's do a little bit of data cleaning. Let's do some tidying up. So I'm going to create a new column that I'm going to copy in the original value so I don't accidentally mess it up. So I'm going to do df, and I'm going to do gender cleaned. Just like that. I'm going to set it equal to df gender. And then while I'm at it, I could actually modify it from here. So I'm going to apply, and what apply does is it will let you pass in a parameter, and this parameter is a function. You pass in a function that's going to modify the text in some way. And in order to make it a lot easier, I'm going to do an inline function just in here with something called lambda x, and then I'm going to do x.strip. And what strip does is it removes all the white space. It removes spaces in between, spaces after or before. It gets rid of the white space that we should ignore. And if you read this, this part of the code, it's going to be apply lambda. It's going to pass in an x, and then that x, you're going to do this step, and then you're going to return it. Lambda is just a function. You could replace it with a function of your own, but we use lambda just because it's an easy way to create an inline function without having to redeclare it somewhere else. So for all intents and purposes, you don't have to worry about it too much. Just know that this is allowing us to make a function without defining it elsewhere. So I want to make sure my step worked correctly, so I want to visualize it. So I'm going to type in gender cleaned, and let me make sure it's working more or less. And it is indeed working, because look at how many less columns we have. It's a lot fewer. So now that we have some progress, let's start making a lot more progress. So I'm just going to copy this part of it so I don't have to retype it. And I'm going to make it equal to gender cleaned. And I'm going to apply another function. I'm going to apply lambda, just like before, x. And this time I want to do something else to x. I want to make it all lowercase. Once you do that, a lot cleaner. But now you notice that, okay, we have a few misspellings and we have a few off cases. There's not a lot of misspellings. We could specifically create cases to handle those. So, for example, let's look at this spelling for male. You notice how they accidentally typed two E's. So, what I'm going to do is I'm going to grab our data frame, the column. I'm going to set it equal to the same thing. But instead of using apply, I'm now going to do replace. Now replace, I'm going to copy in the exact misspelling, M-E-E-E, and then I'm going to create a comma and then put what I want to replace it with. So I want to replace it with male. And then I'm going to do that for the other misspellings. I'm going to run it, make sure it works, and boom. And now I'm going to do the same thing for the female misspellings, just like that. And boom. Now we have officially created a clean, concise version of the original CSV file that's a lot easier for us to read, and it's a lot better visualized on the computer. Now we can now that we have two types of charts, we have a bar chart and a pie chart. Let's introduce one more. Let's introduce our final one for today, which is going to be scatter plots. And the unique part of scatter plots is that we actually require two columns to work with. Scatter plots need an X and a Y, and we have to provide data for both. So I'm thinking, let's look at the correlation between reading and writing exams. If we look up to our original data, we'll notice reading score and writing score are two columns we can use, and I think it's a good idea to see if we could find some kind of correlation between that. So what we're going to do is we're just going to go dot plot. We're going to go dot plot. I'm going to do, and then we're going to put in a bunch of parameters. So what kind do we want? We want a kind that is scatter. What do we want our X to be? So this is going to be our first. And this is where we put in the name of our column. So we're going to put writing score. Don't forget the commas at the end. I have a habit of forgetting those. We're going to forget column. And then we're going to set our Y equal to our reading score. Now we could go ahead and just run it and see if it works. And voila, we have a scatter plot that compares reading and writing scores. I could go ahead and change color and change font size. So I'm just going to do that real quick and just make sure I haven't broken anything. And now we have our first scatter plot. And I'm just going to call it, scatter 1 instead of graph 1. Just make sure it still prints. Perfect. Now that we have that, let's go ahead and create a correlation between the other types of exams. And as you can see, it's quite interesting. Look at the correlation. Writing score and reading scores are a lot straighter. They're a lot more grouped up. But the math score and reading score are wider. There's a wider correlation, which I guess makes sense in my eyes because reading and writing kind of go hand in hand. But math and reading are kind of polar opposites. So it would make sense that someone might be better at math but worse at reading, or vice versa. So it's a very interesting correlation. But now that we have that, let's create the very last possible scatter plot that we could create using these two columns. I'm going to run it. Hopefully it doesn't break. Works just fine. And once again, we notice a scatter plot that is quite wider. Again, writing and math, not the closest correlation when compared to reading and writing. So we have now officially created scatter plots, bar graphs, and pie charts. We've also learned how to print out segments of our data. We've also learned how to use parameters to modify how our charts look. We at the DSA team truly hope you guys have learned something. You guys have been able to follow along and that our lessons have been helping you guys out. So have a wonderful rest of your guys' day. Don't forget to leave a like and subscribe, and good luck.